My name is Nivedita Gupta, and I'm a professor in the Chemical Engineering Department. I've been at the university for about 18 years. So if you've ever used a glue gun, you've seen that for materials like glue, when you detach the gun from it, you get these long strings that still stay attached to the glue gun itself. Materials like glue and other adhesives are viscoelastic materials. What that means is that they have properties which are like a fluid, like a liquid. When you apply a large enough force on them, and they will flow easily, but they also behave like a solid. When this force is removed, they try to go back to their original shape. And when we are dealing with materials like these, you need special techniques, and that's what our invention is about, to have this special technique for breaking off pieces of viscoelastic material very cleanly at high speeds. So the invention itself uses a stop flow technique, where we use a second fluid, either air or oil, to detach this viscoelastic fluid or a plug of this viscoelastic fluid. So you can see this technique in this video, where we have the viscoelastic fluid shown as a dark fluid in the vertical channel, and we are using a second fluid, silicon oil in this case, to flow in the horizontal channel. We first flow the viscoelastic fluid, the dark fluid, so that it fills up the horizontal channel, and we then stop the flow. When you stop the flow, the viscosity of this viscoelastic fluid goes up, sort of like a solid, and then we use the silicon oil. We reverse the direction of the flow in the silicon oil so that the plug breaks off just like a solid would. We then reverse the direction again to go back in the original flow direction, and you can remove the plug itself from the channel. That's how we get these plugs breaking off cleanly. This technique was actually discovered quite serendipitously by my collaborator and co-inventor on this patent, Brian Zukas, while working on his master's thesis. There are many applications that would employ some process like this, a technique like this. There are a number of other viscoelastic materials that you can use, that you see in real life. Examples of these are suspensions, like solid suspensions like paints and inks. We also have biological solutions like saliva, DNA solutions, mucus, cell suspensions that also behave as viscoelastic materials. So one of the very beneficial applications of this, or applications that would greatly benefit from this technique, is additive manufacturing or 3D printing, specifically as it's being used more and more for developing or for manufacturing plastic and polymer parts, and in bioprinting of tissues or biological structures. In dispensing of viscoelastic materials, just like the glue gun, when you dispense the material, you have these long strings attached which are eventually not useful. So you can have a very large amount of waste as a consequence of material that can sometimes be very expensive. And what the stop flow technique does is it basically reduces that waste by having clean breaks and dispensing exactly the amount of material that you want dispensed for any given application.